Namaste children. Today we learn about some special triangles in which all the sides are equal and all the angles are equal. That is called equilateral triangle. ABC is an equilateral triangle in which all the sides are equal and the angles are equal to 60 degrees. And another triangle isosceles. A, B, C, in which two sides are equal and the third side BC is different. Here side means length of the sides. Lengths of the sides are equal in equilateral triangle, and in isosceles triangle two sides are equal and the length of the two sides is equal and the length of the third side is different. And AB and AC are two equal sides in length and BC is different. Here BC is called base of the triangle and these two angles are called base angles and these are equal. What are the properties of equilateral triangle? All the sides are equal and all the angles are equal to 60 degrees. Sides are equal means the lengths of the sides are equal and each angle is equal to 60 degree and they are equal. Measure of those angles. In isosceles triangle, two sides are equal means lengths of two sides are equal and the third side is different of different length. This side of different length is called base of this isosceles triangle and the angles formed at the vertices end points of this side or base BC are equal. We say that base angles are equal. So this is about special triangles and let us study about the lengths of the triangles. Here the property of a triangle is the sum of lengths of two sides of a triangle is always greater than the third side. Here in this any triangle A, B, C. Length of AB plus length of BC is always greater than the third side AC. Here AB, BC. If you add the lengths of these two, this length is always greater than the third side. Similarly, we have three pairs of sums. How? BC plus CA. BC plus CA is greater than AB. And AB plus AC is greater than BC. This is about the sum of lengths. Of sides. Now, difference of lengths now. Difference of lengths of sides. Here we subtract one length of the side from another length of the side. Whichever is greater, you have to take that length, and whichever is smaller, you have to take that length. And if you find the difference, it is always less than the third side. BC minus CA is always less than AB. Then CA minus AB is always less than BC. So these are some properties of a triangle considering the lengths of the sides. If the lengths of the sides are equal, then all the angles are also equal. That is called equilateral triangle. If two sides are equal and one side is different, we call it as isosceles triangle. Here, side of the triangle we consider as lengths of the sides. The length of side AB, length of side BC, length of side CA is equal to each other in this equilateral triangle. In this isosceles triangle, length of side AB and length of side AC is equal, and the length of the third side is different. Therefore, this is called isosceles triangle. And the different side means side of different length is called base of this triangle, and the angles formed at the vertices or the end points of this side are called base angles, and base angles are equal. So now sum of lengths of sides. If you add any two sides of a triangle, it is always greater than the third side. If you add these two sides, lengths of the sides, the sum is always greater than the third side. If you add the lengths of these two sides, and it is always greater than the third side. And what about the difference of the lengths? If you subtract AB from AC, it's always less than BC. Similarly, if you subtract CA from BC, then it is always less than AB. CA minus AB. If you subtract AB from CA, it is always less than BC. So, these are some properties of triangles. If these properties are not fulfilled, these conditions are not fulfilled, then a triangle is not formed. So, let us continue with the exercise 6.4. Till then I wipe this board. You please try with exercise 6.4. Before that, you go through the solved example in the textbook. Hope you understand it. I'll explain it when I complete this wiping. Try to understand the solved example in the textbook. More examples you solve, you will be perfect. What the solved example says? Yes. Example 3. Is there a triangle whose sides have lengths 10.2, 5.8, 4.5 centimeters? Example 3 of the textbook. 10.2 centimeters, 5.8 centimeter, 4.5 centimeter. The lengths of all the three sides of a triangle are given. Is there a triangle? We have to check whether a triangle is formed with these lengths of sides. How to check it? By using that property, sum of lengths of two sides of a triangle is always greater than the third side. We have to consider all the three possibilities. If one of the possibility is not fulfilled, then a triangle is not formed. A triangle to be formed, the condition is all the three possibilities should be fulfilled. Here 10.2 plus 5.8 is equal to 8, 0, then 16. It is 16 centimeter and is always greater than 4.5 centimeter. Am I correct? Yes. Then 5.8 plus 4.5. 5 plus 8 is 13. Carry 1. 5 plus 5 is 10. 10.3. And it is greater than 10.2. And the third possibility is 10.2 plus 4.5. This is equal to 5 plus 2, 7. 10 plus 4, 14. Is greater than the third side, 5.8. Therefore, the triangle is possible. Now the example 4. The lengths of two sides of a triangle are 6 and 8 centimeter. 6 centimeter and 8 centimeter. Next, between which two numbers can length of the third side fall? Between which two lengths means the smallest side, the difference. The difference will be, the smallest measure is the difference. Here the difference of 8 and 6 is 2. And the sum is 6 plus 8 is equal to 14. What is the condition to form a triangle? Sum should be less than the third side and should be greater than the third side. Means third side should be greater than 2, less than 14. Side should be greater than 2 and less than 14, so that 14, which is the sum, is greater than the third side. Third side is less than 14 and third side is greater than the difference. Sum should be greater than the third side. Difference should be less than the third side. This is how we have to calculate the third side. Did you understand? If you have any doubt, please ask me in the comment box so that I will explain. Now start with the exercise 6.4. Exercise 6.4. The first one. Is it possible to have a triangle with the following sides? So first question is 2 centimeter, 3 centimeter, 5 centimeter. By mere observation, we could see that 2 plus 3 is equal to 5. But what is the condition for the triangle to be formed? The sum should be greater than third side. Here the sum is not greater than the third side. Here the sum is not greater than the third side. Therefore, triangle is not possible. Now the second one. What are the measurements given? Lengths of the sides are 3 centimeter, 6 centimeter, 7 centimeter. 3 centimeter, 6 centimeter, 7 centimeter. So all the possibilities are 3 plus 6 is equal to 9, greater than 7. 3 plus 7 is equal to 10, greater than the third side 6. Then 6 plus 7 is equal to 13, greater than the third side. So, therefore, the sum is greater than the third side. Therefore, the triangle is possible. Okay, this is how we have to check with the conditions and come to the conclusion that whether the triangle is possible or not possible. Now the third question. 6 centimeter, 3 centimeter, 2 centimeter. Here, by mere observation, we can see that 6 plus 3 is greater than 2 and 2 plus 3 is not greater than 6. Here, 2 plus 3 is 5 is not greater than 6. Therefore, the triangle is not possible. Then the second question. Take any point O in the interior of a triangle PQR. Is these three questions are correct. OP plus OQ is greater than PQ. OP plus OQ. OP plus OQ. Here, if you join O and P, O and Q, here the triangle is formed. Therefore, when there is a triangle, the property of it is sum of lengths of two sides is always greater than the third side. The first question is yes. Then the second question. OQ, OR. OQ plus OR is greater than QR. Is it true? Let us check. OQ, OR. OR will join OR. Here OQR triangle is formed. Therefore, by the property of the triangle, sum of lengths of the two sides is always greater than the third side. Therefore, OQ plus OR is greater than QR. Yes. Then the third one. OR plus OP is greater than RP. OR plus OP is greater than RP. OR, OP. Yes, ORP is a triangle formed here. Therefore, the sum of lengths of two sides OR and OP is always greater than the third side PR or RP. Yes, this is how we should be reason out the steps or our observation or our fact, our answer. Okay. Now the third one. AM is a median of a triangle ABC. ABC. AM is the median means BM is equal to MC. Third one. Here AM is median. Therefore, BM is equal to MC and BM plus MC is equal to BC. Okay. What we have to show is AB plus BC plus CA is greater than 2AM. By using the property of the triangle, sum of lengths of two sides is always greater than the third side. Here we consider two triangles. This one and this one. So in triangle ABM, AB plus BM is greater than AM. This is the first inequality. In triangle AMC, AC plus MC is greater than AM. This is the second equality. By adding these two, AB plus BM plus AC plus MC is greater than 2AM. Right? But BM plus MC is BC. Therefore, AB plus BC plus CA is greater than 2AM. Okay? You have to write the reasons here. Because sum of lengths of two sides is greater than third side. Here I didn't have space to write, so while writing, this reason should be right side of your notebook, of the page of the notebook in which you are writing, prayer book or your practice book, whatever it is. Write the justification here with reasons to your right side. Try the next one till I wipe the board. For every step, you have to write the reasons. Why you wrote that? Whether it is an inequality or an equation or a conclusion, whatever it is, why you come to that conclusion? Why you write that equation? Why you write that inequality? Always you should write the reason to the right of that step. Now the fourth one. ABCD is a quadrilateral. CD and diagonals are AC and BD. We have to show that AB plus BC plus CD plus DA is greater than AC plus BD. Or is it true? We have to check with it. For that, we have to consider first A, these two triangles. A, B, D, C. Consider these two triangles. In these two triangles, in triangle ADB, length of side AB and length of side AD is greater than the third side BD, because lengths of sides is sum of sides is greater than the third side. And in triangle, let this be first equation. in triangle ABC, AB plus BC is greater than AC. Second equation. The reason being sum of lengths of two sides is always greater than the third side. In triangle, we'll consider other triangles. ADC. In triangle ADC, BC plus CD is greater than BD. This is the third equation because sum of lengths of two sides is always greater than the third side. In triangle ACD, AD plus CD is greater than AC. The reason being sum of lengths of two sides is greater than the third side. Adding all the four inequalities, what we get? Did you get, children? By adding them, what did you get? All the inequalities. The left side and sides of the four inequalities are AB plus AD, then AB plus AB plus BD it is, right? In triangle ABC, ABC, AB plus BC. In triangle ABC, AB plus BC plus AB plus BC, and the third inequality plus BC plus CD, and the fourth inequality AD plus CD plus AD plus CD is greater than BD plus AC plus BD plus AC is greater than BD plus AC plus BD plus AC. So here lengths of the sides are taken twice. Therefore we can write 2 times AB plus BC plus CD plus DA is greater than 2 times AC plus BD. Therefore, AB plus BC plus CD plus CA is greater than AC plus BD. Yes. Our answer is yes. Now the fifth one. Just try till I wipe the board. You try with 4 triangles formed inside the quadrilateral to prove the fifth question. Just read it. It says the sum of all the sides of a quadrilateral is less than twice the sum of the diagonals. What it reads? The fifth question is sum of all the sides of a quadrilateral is less than twice the sum of diagonals. Let the point of intersection of the diagonals be O. Fifth one, in triangle AOB, AB is less than AO plus OB. Reason being, sum of lengths of two sides of a triangle is greater than the third side, or third side is less than sum of other two sides. This is first inequality. And in triangle BOC, this one, BC is less than OB plus OC. This is second, reason being the same. In triangle OCD, CD is less than OC plus OD. Reason being, third side is less than sum of the other two sides. In triangle, this one, AOD, AD is less than OD plus OA. So these four inequalities we find. Using these four inequalities, we will show that the sum of all the sides of a triangle, quadrilateral, is less than twice the sum of its diagonals. Now add all the four inequalities. AB plus BC plus CD plus DA is less than AO plus OB plus OB plus OC plus OC plus OD plus OD plus OA. Here, in this quadrilateral, OB plus OD, OB plus OD, and AO plus OC. AO plus OC is AC. OB plus OD is BD. Again, OB plus OD is BD. And OC plus OA is AC. This is less than this. Therefore, AB plus BC plus CD plus DA is less than. Here, AB plus BC plus CD plus DA is less than. That is. Therefore, this is less than twice into bracket AC plus BD. So, this is how we can write our justification. Now the sixth one. Try to read it. We have solved it in solved examples. In the textbook, one example of that type is solved. How? The sum of two sides is always greater than the third side. If two sides, lengths of two sides are given, then take the sum of it. The third side should be less than it, and take the difference of it. The third side should be greater than it. Don't be confused, children, with less than and greater than sign. You can check with your friends, discuss with your friends, taking some measurements, and practice the example so that it will be perfect. And you should remember these basic points so that when we go to further classes, higher classes, they are used. Sixth one. The lengths of two sides of a triangle are 12 centimeter and 15 centimeter. Here we take the sum of lengths is equal to 12 plus 15. This is equal to 27 centimeter. And the difference of length is equal to 15 minus 12 is equal to 3 centimeter. So the third side should be greater than 3 centimeter and less than 27 centimeter. So that sum of two sides is always greater than the third side and the difference of two sides is always less than the third side. Here the third side should be greater than 3 centimeter and lesser than 27 centimeters. Here the sum of two sides is 27. Therefore, it should be greater than the third side. And the difference should be less than the third side. So, our third side should be greater than 3 centimeters and lesser than 27 centimeters. Okay? If you have any doubts, please ask me in the comment box. I will answer you. Okay?